I don't always go about by daylight, but when I do, it's to take reference images. In the last few weeks, my friend Zane from Zane Morgan Crafts has made some great Blender tutorials for 3D printing. My modeling process is a bit different from his, but he got me thinking. I do not have a 3D printer and I am not planning to get one, as I would end up knee-deep in unpainted minis, but I do have access to a few 3D printing services, so I figured I'd take a shot at making some elements, which would be really fiddly to make by hand. Something like these balustrades, which are a pretty common architectural element around here. I will be linking the references, blend files and the STL files in the description below, in case you want to follow along. I'm Carl and this is Carl Makes Stuff. I'm going to start off by going into the orthographic mode and hitting Shift A to add my reference image. Next, I'm going to hit Shift A again and add a Bezier curve. You won't be able to see this right away because it's laid flat at the moment, so I'm going to hit R for rotation and Y90 to turn it upright. Now we can see it's back to orthographic view, where I'm aligning the curve to the reference image using the G key. It doesn't matter where it sits exactly, as long as it's somewhere along the edge of the profile we want to trace. Once it's in place, I hit the Tab key to go into edit mode. These pink lines you see are the handles for the curve, and their length and angle controls the curve. You can move the endpoint by moving the middle dot by selecting it and pressing G, and change the path of the curve by moving the dots at the end of its handles in the same way. Since this shape includes some sharp corners, I am activating snapping by pressing Shift-Tab and switching it to vertex snapping. This will make it easier to move handles when I need super tight corners. It won't be needed most of the time, so I will be switching it on and off as we go. From here, I align the curve to the profile. You can be as precise or rough as you like, but you're still going to be using the same set of actions over and over. Move the point with the G key and move the handles to rearrange the curve. Once I have the initial curve where I want it, I use the E key to extend another segment and play around with it till it's where I want. When I want a sharp corner, I enable snapping by pressing Shift-Tab and bring the handles in with the G key. From then on, it's just a case of repeating this over and over until I have a profile running from top to bottom. With the profile complete, I'm going to tab out of edit mode and convert the curve to a mesh by going to the Object menu, Convert to, and selecting Mesh. Next, I'm going to bring it in a little closer to the vertical axis. This process I'm going to do will turn the profile around this, so moving it closer will make it a bit less chunky. Now, when I tab back into edit mode, you're going to see that the profile looks different from what it did, because we changed it to a mesh. We also have a whole lot of different tools available now, so I'm going to select all the points using the A key, then pick this pin tool. Now, you can control it with the mouse, but since we want a clean 360 anyway, I'm going to go to this tool window, make sure Auto Merge is selected, and type in 360 for the degrees. We really want a closed shape, so we need to close up the top and bottom. To do this, I'm pressing 2 to go to Edge Selection mode and selecting one edge from the top. Now, you could select the entire rim edge by edge, but instead I'm going to go to the Select menu, select Loops and Edge Loops. This selects the entire rim, so I can now press F to close it up before I do the same on the other end. The shape is there, but it looks a bit jagged, so I'm going to tab out of edit mode and apply a subdivision surface modifier to smooth it out. That looks good, so all I need to do to finish the baluster off is to add a couple of blocks. Now this is super simple, as I'm just adding a cube, scaling it with the S key and moving it with the G key until it's where I want it to be. Then I make a duplicate using Shift D and move that to the other end. Ta-da! Of course we can make other shapes this way, like this bell. The process is exactly the same, so I'm just going to speed through the first part so we can get to the interesting bits. To make the mounting point at the top, I'm going to start with a cube. The process should be familiar if you followed Zane's tutorials, but I'm lazy, so I'm going to do half of it, and use a mirror modifier to duplicate it when I'm done. I'm going to start by making a loop cut through the middle and deleting the faces on one side. Then I make some horizontal cuts and extrude that little loop all the way around, occasionally adjusting the vertices for a cleaner curve. To make the hole, I make some more loop cuts and delete some faces to make space. Then readjust the vertices to create a semicircle. Then I select opposite edges and use the F key to create new faces on the inside of the hole. And with that, I just add a mirror modifier and have it reflect on the y-axis to get a complete mount, and a subdivision surface to smooth it out. Now, this bell is a little plain, but I think it will make a good base model for modifications, so I can add more stuff on top later to decorate it. As a proof of concept, I'm going to drop an inscription on it and see how that goes. Obviously we'll need some text, so let's get that out of the way. Shift-A to add a text object, then I hit Tab to edit it and type in the inscription. Then I'll use the text properties to give it some thickness, change the font and alignment, and all the usual stuff. Next, I go to the Object menu, set Origin, and select Origin to Geometry. This moves the reference point for the text to its center, which will be important later, and apply transforms to look in the size and position changes I made. To make the text go around the bell, we need a curve object to shape the text around. So I'm going to select the bell and pick an edge loop. Then I'm going to duplicate this by pressing Shift-D and pressing Enter. Finally, I press P to separate the copy from the rest of the bell. Next, I tab out of Edit mode and select the edge loop, and convert it to a curve by going to Object, Convert to, and Curve. Finally, I press Shift-S and select Cursor to Selected, which will move to the 3D cursor to the position of the curve. To get the text formed around the curve, I first select it and press Shift-S. This time I pick Selected to Cursor, which will move it to the position of the 3D cursor. Next, I add a curve modifier to the text, and use the curve we just created as a curve object. This bends the text, but I need to change the deform axis to find the one that fits, and rotate the text around a bit so it's the right way up. After that, it's just a case of repositioning stuff till it looks right, and turning the mounting point so it's aligned with the text. And that's the bell done, and all that's left is to export it to an STL. Now the problem is, I have no clue how 3D printing works. If only I could check with someone to see if these will print.
Hello everybody, I'm Zane Morgan. Let me start off just by saying the way that Carl used the curve to make the meshes, that just my mind. So I've been using Blender for years, and what I love is there's still ways to do things, workarounds, and it's just a wonderful program. So the way Carl made it is a wonderful way that I had never thought of doing. The way I do it is slightly different. Watch my video to see my process, but Carl asked me to look at his models and see if they were printable. So that is what I'm going to do. Let's head over to the computer. So yeah, here it is on the screen. This is his bell. And let's see, as far as everything in Blender, it looks good. My only concern, the connector piece is really small, or thin rather, and that might be a problem in the print. It will definitely print, but it's just going to be really, really thin. So my suggestion for that would just be to beef it out a little bit. With 3D printing, especially with miniatures, especially if you're going for the 28 millimeter scale, you want to exaggerate the size of some things just because of how tiny they're going to print, especially if you're going to be doing it for wargaming or D&D. The small bits, they'll become very fragile. And if you're going to be playing with it, then you want it to be beefed out a little bit. That's why on, say, like this miniature, the staff in relation to his hand is thick. It's very thick, and it doesn't really make any sense scale wise. It's just more for durability. So as far as your bell, that's all I would change. Let's bring this into Chitubox, which is the slicing program I use. So this is the file. The other thing is you want to scale it, but you can easily do that in the software. So let's scale that up. Now right away, the issue here is the normals are messed up, and that's common, especially if you're not used to 3D printing. I always suggest when you're in Blender to go in and flip the normals, which I'll show you how to do. But this dark blue color, that means that it's not going to print. The printer software is ignoring that. So what we're going to do, we're going to go back into Blender here. We're going to select all by hitting A, go under edit mode, select A again, go under mesh, normals, and recalculate outside. It's that simple. So I always do that right before exporting an STL just to be safe. So we're going to re-export that. And now we're going to open that file back in Chitubox, scale it up. So now see how this is all uniform color? That's what we want to see. That means that it's going to print. So we're going to throw some supports on, and I'm just going to auto generate these, and we'll print it out and we'll see what happens. Here it is fresh off the printer with the supports. Looks good. Let's pull it off the supports and clean it up. Voila. So right off the bat, this definitely needs to be thickened. It's about not even a millimeter thick, and it is pretty much translucent. And yeah, this will definitely break off in normal play, or if it falls, definitely has a potential of breaking. Other than that, it looks beautiful. So great job, Carl. Keep up the good work. And yeah, I hope this helped you.
Thanks for the advice, Zane, and thank you all for watching. I hope you enjoyed it, and do check out the free STLs in the description. I do have more Blender content coming up before I get back to more traditional builds, but in the meantime, stay safe and see you around.